All right, folks, this is taking 30 kilograms, which converts into 30,000 grams, and we're taking that 2,000 degrees at Celsius, so we're talking about a liquid. It's right on this slope right here, so I put an X at the start, so that's 2,000, and we're going to take it all the way down to 20 degrees Celsius, and that is going to actually put us in a solid, and then it's going to finish us up right there. So we're going to cool that liquid steel down, and then we're going to solidify it. We're going from a liquid to a solid, and then finally, once it's a solid at 1,538 degrees Celsius, still very hot, we're going to cool it all the way down to 20 degrees Celsius. I'm going to show you how we're going to do it in 3 steps. So here's the first step. So step number 1, we are going to take our change in temperature. So I am looking at the change in temperature, and the change in temperature is going to be at 1,538. That's going to be my final temperature in degrees Celsius, and we've started at 2,000 degrees Celsius. So that delta T ends up being a negative 462 degrees. So remember, we are cooling this down, so we have to reduce the temperature. So 2,000 minus 1,538 is going to get you to 462. Another way of thinking about it is the final minus the initial, and that's how you're going to get the negative. So you need to have a negative delta T in there. And I'm going to take that 30,000. So Q is equal to the mass times the specific heat times the delta T. So my mass is 30,000 grams. I'm going to use the 0.82 joules per gram for every degree Celsius, and I'm going to multiply that by the change in temperature, which is negative 462 degrees Celsius. And I'm going to do the calculation on that in a second. I'm going to cancel out my grams, cancel out my degrees Celsius, and my Q for this ends up being somewhere around 1.14 times 10 to the 7th joules. Right? So I have my 462 multiplied by 0.82, and I'm going to multiply that by 30,000. Yep. My calculator tells me 1.136. I'm going to round that up to 3 digits. The reason why I'm picking 3 digits is because of that change in temperature. I'm not going to pick the 5 digits of the 30,000 grams. I'm not going to pick the 0.82 since that's a constant specific heat. So there's my step 1 change, and that should be a negative as well. All right, so the next thing, my step 2. My step 2 is a little bit easier. Still, it is a 30,000 gram, but it's just going to be multiplied by negative 247. So I'm going to say Q is equal to my mass times my my heat of fusion. So HF. So my mass of 30,000 grams. The heat of fusion on this is negative 247 joules per gram. Now, I'm using negative because I'm removing energy. Why am I removing energy? Because I'm taking it from a liquid to a solid, and you have to remove energy to do that. If I was taking it from a solid to a liquid, that number would be a positive energy change. So therefore, my Q on this is going to be a negative. Again, I'm going to use scientific notation, 7.41 times 10 to the 6th, a little bit smaller of a number in joules. So 30 times 30,000 times 247, and I get to 7.41 exactly. So, and again, it's a negative number. So my step 3. So my step 3 ends up being fairly similar to step 1, but my delta T in this case is going to be that 20 degrees. That's my final degree Celsius, and I need to cool that 1,538 degree Celsius solid. My delta T ends up being a negative number on this one, and the negative is a fairly large 1,518 degrees Celsius. I am now going to take that and multiply by my mass again, multiply by, this time, the specific heat of a solid, which is 0.412 joules per gram for every degree Celsius, and I'm going to multiply it by that delta T, which is 1,518 degrees Celsius. And my Q on this, when I do the math, I'm always double checking my math because you can never just do this once, just in case you plug in the wrong number, you round when you shouldn't have, whatever it is. And in this case, my Q is equal to, I'm going to go again, 1.876, which is going to be for me 1.88. I'm taking a 3 digits this time. Another large number, 10 to the 7th joules. Again, that's negative. Why? Because of our negative change in temperature. So I'm going to take my 3 and I'm going to add them all up. When I do, I should get a number like my total Q is going to be a total of these 3, small number to larger numbers, of 3.76, right, times 10 to the 7th. And if I were to write that out, and that's negative again, I'm taking energy away. I'm going to move that decimal over 1, 2, 3, 4, 5, 6, 7, and I'm going to put a comma in. Here are my commas. My comma goes there. My comma goes there. And of course, it's going to be a negative, and it's in joules. So negative 37,600, negative 37,600,000 joules of energy needed to remove molten or liquid steel that starts out at 2,000 degrees Celsius, and we have to take it down to a solid that's 20 degrees Celsius. And that's how much energy I need to remove. Hopefully that helps. Let me know if you have any questions.